Alrighty. Hi, everybody. Welcome back. We are headed into our money math chapter, our money math unit this time. We are going to be starting with percent, but as a reminder, please make sure you're finishing up that voting unit information and uploading clear scans as required. Here, we're going to be talking about money management, and actually, one of the most important concepts in money that actually comes out really early is percent. Percent. And as I mentioned in class, I really love the word percent. Percent is actually telling us what it is right away. And it's so good. I love it. Okay. So while we're going through this section, please make sure you keep our goals in mind and you be thinking about your particular money goals. I do want us to talk quite a bit about how money is involved in your life and some goals we should all be having and thinking about while we're working with these different calculations, tabulations, and other sorts of math ideas. So percent. There are 100 cents in a dollar. There are 100 years in a century. There are 100 soldiers in a centurion, and there are 100 parts per cent. Oh yeah, I just said the same thing twice. It's a little bit silly. The exact definition of percent is parts per 100. Okay, so parts per some sort of ratio that's going on, and we use this sign to indicate when a number represents that ratio. We use our percent sign, and I love this percent sign. This percent sign is so cool because it kind of, if you turn it over a little bit, looks like something divided by something, right? And also, if you take that line out to the front, it also looks like 100. So together, it makes up the whole idea of parts per 100. So it's all together in the sign. Oh, so good. So we'll be looking for that percent sign to let us know we're in percent form. Now that's very particular because we actually need to convert it to its decimal form to be able to use it in most of our calculations and tabulations. The math we do with percent needs to be done in its decimal or fraction form, preferably its decimal form. What's really cool is our calculators can help us with this a lot. A straight conversion, if we see something in a percent, like say 50%, to convert it to its decimal form, we can divide by 100. Okay, so divide by 100. Or one of the tricks you may have noticed is that if we have something and we divide it by 100, I can take that decimal and move it two places to the left. Move the decimal twice, just two spots, twice left. So let's look at some of these different conversions down here. Here we're going to convert percents to decimals and decimals to percents. And I'm not going to automatically tell you which one it is. That's something that we need to be able to look at and see. Do we have a number in decimal form or a number in percent form? So in this first one, we have a 20 followed by that percent sign. Since it is a percent, I need to make sure that we put it into its decimal form. And so what I can do is I can take 20 divided by 100, or again, I can take that decimal and move it two places to the left. If you look at your calculator, let's take a quick peek real fast. For our calculator, 20 divided by 100. Oh yeah, same thing. 0.20. I put that extra zero there just to see that zero that we actually moved over from, but you don't need to include that. 0.2 would be just fine. Now, because it is in its decimal form, I do not want to include that percent sign again. Okay. Ooh, but our next one is weird. Our next one doesn't have a percent sign. So if it's in our decimal form, this case, a decimal or fraction form, I love our calculator. Watch this. 1 divided by 8. Boom. Okay. Right there, I can put it into a decimal. This is the exact same thing as 0.125, and I need to reverse my process. So I have two choices. I can multiply by 100. See over there on the calculator, multiply by 100, and we get 12.5%. Or I can move my new decimal place two spots to the right, and we get the same thing, 12.5%. Since I changed it into a percent, I went ahead and put that percent symbol on there to let myself know it's been converted. Ooh, this one's a little crazy. It looks like it's in decimal form because it is 0.043, but then the percent sign says it's a percent, which means I still need to divide by 100 or move my decimal place 2 spots back. So I could do 0. Ooh, I need another 0 there. 3 zeros and then a 4, 3, or I can take 0.043 and divide it by 100, and I get the same thing either way. Now we're in our decimal form because we started percent, now we're decimal. In this next one, I see a decimal but no percent sign, so I need to change it into a percent, which again means either multiplying by 100 or moving that decimal 2 spots to the right. To get into percent, 2 spots to the right. To get it out of percent, 2 spots to the left. It's kind of nice because if you see the little percent sign, it tells you need to move twice, the little 2 zeros. Okay, so 91.2%. All right, I'm actually going to go ahead and leave these next 4 for you to go ahead and complete and try. Give it on your own. Now I want to move on a little bit to the very specific way I want us to be thinking about calculating total percent or part. Total percent or part. Okay. I want you to rewrite this specific outline several times on your work, and I will be looking for it. We will be using the either total or base. I actually like to use the word base. Base times percent. Now, here's the problem. I just said that when we do percentages in calculations, it has to be in its decimal form. So I'm going to change this last little 0 to a little d to remind myself decimal form. Decimal form equals result or part. Result. Okay. I don't love the idea of total or part because of some of the English that's going to come into this. So I would like you again, highlight, underline, make sure it is obvious to you. Base percent decimal equals result. That's what we're going to be using in our class. Okay. This might be a good one for your name tag too when you head in. Okay. So remember that percent decimal really means the percentage in decimal form. Now, you will also see several other formulas in the book and homework where they take this formula and they rearrange it according to those solving rules that we saw from chapter 3, the order of operations business. For instance, if I have base times percent decimal equals result, and I need to find the percentage. The percentage is the thing I don't know. Then I will divide both sides by the base. And I will find out that the percent in decimal form is equal to the result divided by the base. Now, some books are going to have you go through and rewrite like 6 different formulas or something, and it all comes back to this. Base percent decimal equals result, just rearranged. So that's why I really like this one. This one's a big one for us. Okay, let's see a couple of examples about how this might come into use. Okay, so find each answer with units if applicable. Okay. What is 30% of 420 shelter animals? Okay. I love very often these questions, these word type questions, because it's going to give you the percentage with either the word percent or a symbol. So check it out. They gave us our percent. That's going to be our percent. We do need to change it to decimal form. Okay. Now it says of 420 animals, of 420 shelter animals, of by itself means multiplication. And this right here is going to be our base amount of animals, our base amount of animals. So when we do base times percent decimal equals result, what we're going to do is we're going to do for 20 animals. Now, I cannot put 30% here. I have to convert it. Boop, boop, convert 0.30 equals, I'm going to do R for result. R for result. Now, as mentioned in the other section, I wish I gave us enough room to move down, but I did not. So I'm going to move back up here and I'm going to look and I'm going to be like, oh, look, the unknown I need is already by itself. So all we have to do is go in and find out what 420 times our 30%. Now, did I need to do a times? Nope. The parentheses in the calculator are going to read it off just right. So it turns out that 126 is our result. 126 what? Well, it turns out if we're looking for 30% of 420 shelter animals, we're actually going to get 126 animals. Boom, right there, ready to rock and roll. Okay. Here for part B, what percent did Anna get on the 132-point quiz if she earned 116 points? This one I love because you, ladies and gentlemen, may have already had different activities, examples, assignments in class, and you got your value out of a total value. And again, it says, what percent? Percent is the thing I don't know. Percent is our question mark. Okay. Now I have to decide if the 132 is the base or the result. Since she earned 116, that will be our result. This will be our base. And so I know when I do base times percent decimal equals result, we will do 132 times either a question mark or a symbol or a P for percent, don't care. A placeholder for the unknown we don't know is equal to 116. And I know by my rules of solving, I will need to divide both sides by that 132. Sorry, got a little smushy. So I get question mark is equal to 116 out of 132. 116 out of 132. Aha! I will be doing some rounding. Okay. This right here, ladies and gentlemen, my percent in decimal form. Now, percent in decimal form is 0.87 repeat. So I'm going to put that little repeat bar on the top. Maybe you remember that little repeat bar. I do love that answer. But since we want to change it into its percent, there are two acceptable answers. So then I can take it and I can multiply by 100. Boom. You can write 87.87 repeat percent, which is an exact answer, or you can do 87.88% because we rounded. Now, how did I know that next number was an 8, that last number? Because the 7 on my calculator is followed by an 8, and 8 tells me to go up. Okay. Oh, this is interesting. This one's a little crazy. If Alex spends $186 on groceries, and this is 120% of the budget, what is the budget? Oh, poor Alex did like Anna and went to the store and spent more than 100% of the budget. Oof, 120% of the budget. Well, let's see. If you spend this much and it says 120% of budget of the thing, that right there is our base that we don't know. There's our percent, and that must be our result then. How much money was spent? So when we do base times percent decimal equals result, we will do a base. I don't know, so I'm going to put B for base. 120% gets converted. Ooh, I could even double check. 120 divided by 100. 1.2. 1.2 equals $186. Aha, and we can see here, I think, that we need to divide both sides by 1.2, divide by 1.2, and we get base is equal to, let's find out, 186 divided by 1.2, and we find out, ooh, Alex, you were only supposed to spend up to $155. The budget is $155. Oof. Good sir, be careful. Okay. I think that for D, E, and F, I would like you to go ahead and complete those and then come on into class and I will be happy to double check them or office hours. But please, please, please give these next couple a go on your own. All right? Because I want to talk about applications involving percents. Okay. Solving application problems involving percents. Problems involving percents. Okay. When answering these questions, we're going to start with reading and underlining and or highlighting. I really want you to be very clear about the important pieces of information. And I'll be honest, the vast majority of the time, it's going to take more than one read through. Okay. For example, Harris works the bookstore in their hometown. During one particular day, the store had total sales of $1,765, of which Harris sold 30%. What were Harris's total sales that day? So Harris works in the bookstore. That doesn't give me any information about a tabulation or calculation. However, it does say during one particular day, the store had total sales of $1,765, of which Harris sold 30%. What were Harris's total sales? So this is one of those types of examples where I want to make sure that we're using our class vocabulary of I need a base, I need a percent decimal, and I need a result. And if a store had total sales, I think that's going to go ahead and total the store's total sales will be our base. Harris sold 30%. Again, I love it. That percent sign tells me that's a percent, and I will need to convert it to its decimal form. In fact, right here, I'm going to say 30% is the same thing as 0.30 decimal form. And then Harris's sales for that day will be the result. What was the result of the 30% being just Harris's? Okay, so that means we have 1,765 times our 0.30 equals our result. You could use R or question mark, whatever you want to use to keep the place value. And on our calculator, we're going to go 1,765 parentheses 0.30. Ooh, all right. So the result is 529.5. And again, our result is amount of money in sales. So it turns out that Harris sold $529.50. Boom. Now it is money, so we can have a partial like 50 cents. If it were something like outfits or pets or siblings or pumpkins, partials might not make sense. So be careful to check the situation, whether or not you're going to need to round. Boom. Go Harris. Nice work. Okay. Now, I would say, and I imagine you would say, that the vast majority of times where you're dealing with percentages in like a general store with money actually has to deal with markups and discounts. Markups and discounts, coupons, sales or markdowns or discounts. Markups is things like increase in rent. Oh, my rent goes up every year, right? Or perhaps inflation values, okay? So the next section that we're going to head into is discounts, markups, and sales tax. These are written vast majority of the time as percentages, and we're going to need to convert back to decimals and work with them in our tabulations. So there's two kind of neat, unique things that come with discounts and markups and percentages. Okay. So discounts and applications. I want us to be extra super clear. If something is 20% off, that means 20% is off. You pay the other 80%. If something is 50% off, you pay the other 50%. Now, there's something about 80/20 and 50/50 going together that's important. If something is 5% off, you pay the other 95%. I hope we notice a pattern here. Okay. So if something is on sale for K percent off, then you will still pay 100 minus K percent of the original price, right? Together, the off and what you pay have to add up to 100%. Parts per hundred, right there. Okay. So what's neat is that if we take 1 minus our percent discount, 1 minus our percent discount, we will get the percent that we pay already in decimal form. Percent pay. So when we have often these discount ideas, we're going to need a 1 minus that. And again, I want you to automatically be thinking, ooh, this amount off, this amount I pay. Okay? So if Julia really wants the Instapot of coals, which is normally $185, but they have a 20% sale on home goods. Good job, Julia. And she has a 25% coupon that was supposed to say 25% off coupon. Coupon. How much will she pay? And is it 45% off? So the vast majority of people are like, sweet, 20% off coupon, 25% off coupon. Hey, look, 45% off. Nope. Nope. I hope you're shaking your head right now. Nope, that's not how we do. Okay. So here, $185 was the base amount for the Instapot. Okay. So again, we're still looking at base times percent in decimal form, but since it's a discount, I'm going to go ahead and do 1 minus the percent discount equals the result. Now, I hope you're like, Anna, this is a new formula. It is not entirely, but you can remember and you can record it differently if you desire. Okay? Remember, 1 minus the percent discount will give you the percent you pay. Percent you pay. All right? So let's go in and let's find out together if I have $185, 1 minus 20%, right, into that decimal form equals a result. Let's see what that result is. Now, this is still the first sale. 1 minus 0.2. After the first sale, we're down to $148. Now, you're not paying that whole $148, Julia. You have another coupon. That is our new base, $148. 1 minus 25%. Oh, because if it's 25% off, you pay 75%. Let's double check. 100 minus 25% off. Oh, yes, you pay 75%. Okay, so I need 148, 1 minus 0.25, and I find out 111. Ah, so Julia will pay, ooh, try again, $111. Okay, let's see if that is a 45% off discount. Well, that would be 185, 1 minus 0.45. Oh no, tis not. Look, it is not a 45% discount. Let's find out what percent it actually is. So $185 minus $111. Turns out there was $74 saved. $74 off. Dollars off, right? 74 out of 185. Let's check that out. 74 out of 185. Aha! Is a 40%. Ooh, look at that. Look at that. A 20% and a 25% resulted in a 40% off. Hey, let's see. Check this out. What I love about doing this is because you're multiplying every time, I could actually take that 185 and do my first discount of 20% and my second discount of 25% right there at once, and I'm going to get to my answer. Oh, isn't that so cool? And I love our calculators. They're so fast. Okay, it is 40% off total. And really, the answer was Julia will pay $111. Ooh, okay. Using the same idea, I would like you to go ahead, pause this video, check out how much percent discount, what the discount is for Christian if he gets $870 skateboard for $609. Okay, give it a go. Give it a go. I hope you had a chance to pause. If John's 20% off burrito costs 4.5, $4.50, less than full price, what was full price? This is interesting because this is not the result value. This is a percent discount. This is a discount value. So we can do this two ways. Two ways. We can use base times as a decimal equals result, where the original base was some unknown amount, 20% off, and the money off was 450. Okay, and the money off was 450. You can see we went right back to that original because my result here is not the result price, it's the result off. The result off. So let's check and see. Here we divide both sides by 20% in decimal form, and we get 450 divided by that 0.2, and it turns out the original burrito was 22.50. Ooh, better be a giant burrito. Okay. Now, hey, Anna, could we have done it the other way? We totally could. We totally could. We would have needed a base price. 1 minus 20% off is the base price minus 450. Base price minus 450. Now this is tricky because we see base, the thing we don't know, in two spots. In two spots. Let me go ahead and replace that base with an X. X. So I have X times, now 1 minus 0.20. 1 minus 0.20 is 0.80 is equal to X minus 450. Now my X's are on two different sides, so I need to subtract or add over to get them on the same side. Minus X, minus X. Well, if you have 0.80x minus 1x, you actually get a negative 0.2 x's, which feels a little weird. That's okay because that's going to equal negative $4.50. And when we take a negative divided by a negative, we get a positive because I divide by negative 0.2, divide by negative 0.2, and we get still a burrito price of $22.5. Oh, yeah, same answer. Same answer. Okay, this is a little bit more advanced. It is important here again to note that the result we got was the money off, not the end price. Okay, that's a little bit kooky, a little bit different. All right. Here on this page is 3 different examples. I think we're actually going to save this for class. Do in class. So let's actually take a minute and let's talk about markups. Markups. You actually deal with markups all the time. You deal with markups every single time you buy anything with taxes on it. You actually deal with markups all the time when you tip a certain percentage. I'll be honest, you really want me as a customer. I always tip. And I always tip pretty well because, service jobs are hard. Okay, so markups are like taxes and tips. It's where you're adding on based on a percentage. Okay, so if a value has a K% markup, if you need to pay taxes on something, you're not discounting anymore, you're adding. So you actually take 100% of the original. You take the whole original and you add to it a K% of it. So I'm hoping as soon as you see this, you'll be like, ooh, remember for markdowns, we did 1 minus. For markups, we'll actually do 1 plus. The percent markup equals result. This is also great when you're working at a job and you get a raise. Raises are by percentages. Okay? Most of the time. I shouldn't say all the time, but most of the time. Okay? So if a local business buys a $120 game but sells it for $190, we see a markup. All right, a markup. What is the percent markup? So here we have a base. Here we have a result. The percent is the thing we don't know. We don't know. You could put percent decimal or percent markup. Okay, so I'm going to rewrite my formula. Base 1 plus percent markup equals result. So we have a base of $120. A 1 plus an unknown markup is equal to $190. Now, oops, I don't need that extra parenthesis. Here's where we want to remember that we're trying to get that question mark alone. We're trying to get it by itself, so I think we should divide both sides by 120 first. And then we get 1 plus question mark is equal to 190 divided by 120. Ooh, I don't love this like rounding thing, so I'm actually going to tap that little symbol and I'm going to change it to a fraction. Because 19 over 12 doesn't have any rounding in it. Oh, I'm so sneaky. I love your calculator. It's so good. Okay, now we're going to subtract 1 on both sides, and I find out that question mark is, let's see if I can do 19 divided by 12, and then over arrow minus 1, and then we get either 0.583 repeat, or again, you can change it to a fraction, but remember, we're actually going to be putting this into a percent form, so I'm going to need to multiply by 100 or move that decimal over, and we get 58.3 repeating percent markup. Markup. Ooh, that's more than a 50% markup. Hoo-wee, look at that. It's quite the markup. Now, businesses often need to do this because they need to pay to, keep their employees and keep their lights on and all that other business. So that's where that can come in very often. All right. Ooh, this one is a big one. I loved my flower arranging class in college. Was one of the best classes I took. But it turns out that the way you actually decide the price of your things helps you keep your business afloat, right? So Lisa knows that she should use a 33% markup on her floral arrangements. It costs $32 in materials and $40 in labor. What would the customer pay? Let's also include a 7.85% sales tax as well. Okay, so we're actually going to do 2 markups. We're going to do a markup based on the markup for the business, and then we're also going to do the markup that is taxes. Okay, so let's see what we got. We first need the base price of the flowers. Base is going to be equal to $32 in materials and $40 in labor, gives us $72. Wowee, flowers are expensive, aren't they? I hope it's a big arrangement. Okay, so now we have this $72 base. We need base, percent markup. We're actually going to do a percent markup for the store and a percent markup for the taxes. So you can see right here, I'm just going to be stacking my percent markups. If you need to see them done one step at a time, feel free to do that too. But I like to do them all together. I have 1 plus. Now, I cannot use 33%. I must change that to its decimal form. And I cannot use 7.58%. I must change that to its decimal form. And I will find out that the $72 to make will actually cost the customer 1 plus 0.0785 with taxes $103.28. Now, why did I round it there? Because cents actually don't go on forever. So I'm actually going to say the cost is $103.28. Ooh, there we go. I bet this bouquet is huge, but it's super fancy. I do like me some fancy flowers. Okay. would like you to take a minute and check on the price, the markup, percent markup for this pricey textbook that Maggie has to buy. Okay. And I would like you to check Tina's hat because of a markup as well. Okay, what's Tina going to be selling this hat for? So feel free to pause the video, check it out, see what you see, write down your work, and I'd be happy to check it in office hours before class starts. There is another page where we're going to be doing a few more percents and percent markups and discounts, that sort of business, but I'm going to let us do this in class. I'm going to say a little in class. You do not need to have it completed for the notes. You can if you want to get a jump start, but we'll also be reviewing it together in our groups in class. I actually want us to do a quick doing markups and discounts at the same time. Markups and discounts at the same time. So, using those parentheses and the one pluses and one minuses to stay organized. As you saw before, we can do all these different things at the same point in time. So Lizette is buying some clothes at Kohl's. She finds 3 shirts that add up to $21, but are 60% off for clearance. If the sales tax is 7.91%, what will Lizette need? So we see a discount of 60% for clearance, but also a markup with taxes. So this one right here will be a 1 minus zero point 0.6. Again, we got to convert. Got to make sure we're still converting for a clearance, but this right here will be a 1 plus 0.0791 for a taxes markup. Now we do have 3 shirts that add up to $21. That's going to be our base. So again, we are going to start with our base. We're going to do a markup and a discount. It does not matter which one you do first at all. Equals a result. Because multiplication, you can multiply in any order we want. We have $21. 1 plus 0.0791. Oops, I forgot my little one. There we go. And 1 minus 0.60 for our discount. Let's see how much we're paying. How much Lizette is paying. Again, doesn't matter which one you do first, and I'll show you on the calculator. There's our taxes, but here's our discount, and where Lizette needs to pay now. Businesses do tend to round up. So even though I will accept $9.06, I also will accept $9.07. Because again, businesses. But let's actually double check. If we took $21 and we did our discount first, oops, I need a 1 minus 0.60. I end up with $8.40, and then $8.40 still has a taxes on it. That's a markup, a 0.0791. Oh, look. Ooh, ooh, ooh. There it goes. Hey, look. Hey, look. Same answer. Now, I know you're like, decimal's a little weird. Don't worry about it. We're all good. We're all good. Might be a little bit of internal rounding, but ladies and gentlemen, you can do it all at once. Okay? This is a very important one to me. A very important idea when it comes to discounts and markups, because some companies will say, hey, take a pay cut now, get a pay raise later, and you don't end up where you started before. Okay? That's very, very, very important. I will actually be doing an appetizer restaurant example in class, but I would like you to take a minute, pause, read through this business here, think about taxes and tips at the same time, and write down what you think the answer will be. And then in class, we'll be doing a really cool one where we actually decide where we're going to eat and how we're going to look at markups and discounts. Okay, so I know that this is a long video. Give it some time. Go ahead, record your notes, scan and upload them, and I will see you in class. Have a good weekend.